Okay, almost finished here. Just looking at real quick 2 more examples. So example 17 is how to solve a fraction, a rational equation, when we've got an inequality. Same rules still apply. I've got a variable in the denominator, so eventually I'm going to have to check some answers out, make sure everything's good to go. But like before, I have a fraction and I want to get rid of whatever's in the denominator, so let's multiply both sides by what's sitting down there. So that'll cancel that off and we'll get x minus 2 is less than or equal to 2x minus 2. And this right here is basically where we've been starting out with some of those prior examples for this lesson. Let's keep our variables on the same side, so let's subtract 2x over. Let's move our constants over, so I'm going to add 2. Okay, so x minus 2x is a negative x. Negative 2 and 2 goes away. 2x minus 2x, and negative 2 plus 2 is 0. So if I'm dividing by negative 1, so I want to get positive x, not negative x, I'm going to put a star right there because I need to reverse that inequality symbol. Again, adding and subtracting doesn't reverse it, only multiplying and dividing by negative numbers does. So there's the answer. As long as I pick values greater than or equal to 0, then I should be good to go. However, I need to come back up into my original problem, because in the original problem I have a fraction, and that x minus 1 right there, that denominator can never equal 0, right? So when I move this 1 over, it's saying x can never equal a positive 1. So let's go to our answer that we found. Our answer we found was the fact that x could be any number larger than 0. But then we also just found that x can't be 1. So how are we going to describe this? Because if you look at a number line, here's 0, and we said it can be equal to 0 and anything larger. And this next part says, well, there's the number 1 sitting in there, and we can't equal that number 1. So how do we describe this in interval notation? Well, you can do one of two things. You could either just say, first of all, your answer, you could say x is greater than or equal to 0, and x cannot equal 1. So there's part 1 of your answer. And how you describe this in interval notation is you say, okay, start farthest left of that shading. The left side of that shading starts at 0. It's going to go up to 1, but I can't equal 1, so I'm going to put a parentheses. But I can pick up right back up at 1 and go off to positive infinity. So I'm going to use a union right in here, the OR symbol. And what this is saying is right here is 0 to 1 includes everything up to 0.999999, just to the left of it. And by putting a parentheses, I'm saying I can't equal it. I'm going right up to the left side of 1. And this right one is saying I'm starting at 1.000001, just to the very, very right of it, and going off to positive infinity. So this is how you do it whenever you want to throw out just one number in there, is you go up to it with a parentheses, go past it with a parentheses, and it does everything except for including it, just like that. Okay, so what I have boxed here in the purples would be your answer for this problem. All right, one last example, and we're going to call this lesson finished. It's going to be number 59 in the book on page 61. So if you guys wouldn't mind, let's just pause it, pull your books out, read through 59, get some thoughts on it, and let's come back together on this. All right, and with this example right here, it's looking like a city is trying to remove some pollutants from its water system. Okay, and a proposal submitted to the city council indicates that the cost in millions of dollars of removing X percent, so the cost of removing so much percentage of the toxin is given by this equation right there. So if I want to remove 10% of the toxin, I would put 10 in for X. If I wanted to remove 50%, I would put 50 in for X. So that's kind of what that fraction is talking about. And then what would come out, so if I want to say I want to remove 50% of the toxin, I put in a 50, what that's going to tell me is then the cost it's going to take in order to remove it. So just kind of understanding what this whole equation is all about. The city could raise between 25 and 30 million for the purposes of removing this pollutant. So what is the range so how much can we be expected to remove? If we have $25 million that we can use or $30 million, then how much can we use? Okay, so the cost basically, we have anywhere from 25 for the cost up to 30 million that we can possibly spend. So what we're going to do is just write ourselves an inequality. We can say that we're going to put this right here in the middle, the 0.5x over 100 minus x, and we're going to sandwich that between 0 and 25 and 30, because what it's finding is this represents the cost. Okay, this is the cost for a specific percentage. And if we know the cost can be greater than 25 million but less than 30 million. So when we solve for x, let's say x comes out to be 10, and then we can remove 10% for sure between 25 and 30. Okay? So just like we've kind of been doing before, let's go up here and just work on solving this out. I've got a fraction here in the middle, so what I want to do is try to get rid of the fraction. And what we might actually do is let's just focus on these in two different parts. Let's focus first of all, so this will be a little bit easier. Let's focus on the 25 is less than or equal to 0.5 x over 100 minus x, and then let's do the other part as being the 0.5x over 100 minus x is less than or equal to 30. So that way we really get a true range of what's going on here. Okay, like always, we want to get rid of fractions. The way to get rid of fraction is to multiply both sides by what's ever in that denominator. Okay, so that's going to wipe that out. 25 times 100 just means add 2 zeros to 25. So 2500 minus 25x needs to be less than or equal to 0.5x. So let's move the x's onto the same side. We get 2500 is less than or equal to 25.5x, because 25x added on to a half is 25.5x. And let's divide both sides by 25.5. Okay, and we'll get a final answer. It looks like, I'll plug this in my calculator just real quick, 98.04 is less than or equal to x. Okay, so we'll come back and interpret that in just a second. Let's go and do the right side real quick. Like I did before, let's go ahead and multiply both sides by that denominator, 100 minus x. Hey, I might go ahead and just cheat it off of that one. So that'll take away, and we'll get 0.5x is less than or equal to 3,000 minus 30x. And just like we did before, let's group these x's together. So 30.5x is less than or equal to 3,000. And if we finish this up by dividing off that coefficient, we'll get x to be less than or equal to 98.36. Okay, so this is saying if we kind of combine these two together, we want to interpret this together as one big unit. So over here on the left it's saying my x value, so my percentage is going to be larger than 98.04. Over here on the left, on the right side, it says though my percentage is going to be less than 98.36. So we're going to be, if I put this kind of like on the number line, here's 98.04, and then here's 98.36. The left one says that my percentage is going to be greater than, so to the right of 98.04, but this one says my percentages have to be smaller than 98.36. Okay, so to answer the question says specifically is what is the range of pollutants that could be expected to be removed. So if you spend, let me write this out in a sentence. If the city spends 25 to $30 million then 98.04% to 98.36% of the toxin will be removed. And simple as that. We are finished with that problem. So hopefully it kind of makes sense. If there's anything in this lesson that you're kind of going back going, wow, especially like maybe before when we were looking at solving the equation that had 2 square roots in it, you've got all the time in the world. Go back and watch this again. This is just for you, so you take as much time as you need to go back over this. Okay?